This is version 2 of a talk that I had originally presented at Ember Berlin last year, where I claimed that I found an opinionated approach to BDD. And much later, I realized that my approach was in fact so opinionated that there was no BDD left in it. So this is a correction of mistakes version of the talk. This talk would not exist without help from my former team lead, Simon Ichmig, who recognized value in my approach and gave me green light to implement it at my former workplace, Kaliber 5, where it proved to be successful, and we started using it in all our front-end code bases. My name is Andrey. I'm an Ember.js enthusiast working for Mainmatter, and I love automated testing. Tests give me confidence. They let me notice regressions before I commit them. They let me refactor code with peace of mind, and refactoring means progress. Tests, acceptance tests specifically, capture business requirements, and I like to enumerate tests before I start implementing them so that I have a nice list to track my progress, and it's also useful to report it, and it gives me this sense of achievement as I am checking out items in it. At the same time, I absolutely hate testing. Every time I open a test file in a mature code base, I have this anticipation that I'm going to have a bad time. The matter is that the quality of test code is typically lower, in my experience at least, than the main portion of the app. This is probably because tests are often written the last thing, and deadlines are already pressing. At the same time, developers realize that test code is not being deployed to production, so they might cut corners. On top of that, as features mature, tests become more and more complicated. They grow with logic, with loops, conditionals, nested loops, and nested conditionals. Seeding patterns become more elaborate and more intricate. And this reaches a point where I think we have all been there, when it feels like it's easier and faster to create a new test from scratch than to figure out and update an existing one. I call this write-only code. If only there was a tool, some test suite that would standardize the way we write tests, that would make tests so readable that they are easy to understand even to non-developers, and that removes implementation details elsewhere so that you can grasp the intention of each test case with a short glance, that would let us write tests fast and enjoy it as we do. Enter Cucumber. It is a library that implements the behavior-driven development methodology. BDD is all about user stories. So when you implement a feature, you are supposed to write a bunch of user stories, like short text describing the behavior of the feature early in the development lifecycle, so that those user stories can be used as specifications for the designer, for the developer, and an acceptance test is supposed to be written for each user story. Cucumber takes this idea to the extreme by making user stories executable. So in Cucumber, user stories are acceptance tests. This is how it looks. The file extension of a Cucumber test is .feature. The syntax is called gherkin, which is a species of cucumber popular for pickling. And the syntax is convenient both to people and machines. It maps really well to Ember.js QUnit tests, or to any test suite for that matter. The name of the feature at the top of this file corresponds to the name of a QUnit test module. Annotations with @marks at top left are initializers that use QUnit hooks. The background section is an equivalent of before each hook, where you do some initialization for every scenario, for every test case. And scenarios are your QUnit test cases. Inside each scenario, there are steps that are executed sequentially. Given steps seed the database and set the initial state of the app. When steps represent user actions, and then steps make assertions. Cucumber is not an AI, unfortunately, or luckily, so we need to implement each step in a programming language so that the Cucumber can execute them. And this is how it works for me in Ember.js. At the top, there is a fragment of a feature file with 2 steps, and at the bottom, I implemented those steps as functions. The name of functions correspond to the name of steps. So I'm going to oversimplify this, but it feels like Cucumber invokes those functions by their names. Functions can be parameterized like this. So if I have 2 similar steps, like I should see 3 posts and I should see 5 posts, I do not need to implement 2 distinct, almost identical functions. I can reuse the same one. And this works thanks to the fact that names of functions also serve as regular expressions. And for each capturing group, you will have an argument with the value captured. You can see a minor inconvenience here. Naturally, regular expressions only produce substrings. And here we need a number, so I had to convert it by hand. But Cucumber also provides converters. A converter is defined elsewhere in your code base. It has a name starting with a $sign, a regular expression with 1 or more capturing groups, and a function that converts the value. So in this case, under the hood, I convert a number string to an integer, but it can also converters can also contain logic. A simple example is when I reference an element by index, like the first post, I would subtract 1 from the number so that the feature file is human-friendly, saying the first post, but JavaScript actually receives the 0th post. Cucumber lets you do multi-line steps. This is to avoid horizontal scrolling with these triple dashes, but you can actually use converters to parse this block of text. You can put anything into it. Oftentimes it's structured data like CSV or JSON. The most popular approach is markdown style tables, and each cell contains JSON. So I remind you that primitive values like number, boolean, and string are JSON. Just don't forget to put strings into double quotes. And the argument that this table produces is an array of objects where each object contains properties with names that correspond to names of the columns. And this is all there is to Cucumber. As you have noticed, it does not have loops and conditionals. And this is very intentional to make scenarios like easy to grasp. According to BDD, if you have a case with a condition that can go one way or the other, this means that you have 2 distinct user stories. This is because with BDD, you could put each of them on a sticky note and move across a Kanban board if you do that thing. So not having loops and conditionals makes your features contain a bit of duplication, but this is the price you pay for making them easy to understand and quicker to work with. Cucumber also supports test matrices. matrices. I mean the plural for matrix. Dude, not this matrix. Okay, thank you, Meme Drake. This may be too bold to call this matrices. It's just an array of test cases. So if I pass this table to the where keyword, I don't pass it to an individual step, but rather to the whole scenario. And this scenario will be invoked multiple times, one for each row of the table. And values from the row will be fed into those square bracket placeholders in names of steps, but also in the name of the scenario, which will produce a nice QUnit output with distinctive test cases. So if one of them fails, you can see which one is to blame. Cucumber has a lot of benefits. Some of them I have mentioned in the beginning of the talk. And I'm not going to go through all of them. I'll just mention that what made me get interested in Cucumber in the first place is that you can create new test cases by having a library of step implementations defined, and you simply reuse names of steps. So you can produce new test cases without writing any JavaScript. And grasping the intention of each test case is so easy, as I have told before. Cucumber has a large army of Avid supporters, but turns out it also has a comparable, if not larger, army of haters, many of whom have started as Cucumber enthusiasts, but then got bitterly disappointed with it, with almost every claim, every promise it makes being false, not delivering on them. So I'm going to go through the major ones to show you how much pain Cucumber is and how I resolve them and why. The first issue is that the library of steps keeps growing indefinitely. So you start with dozens, then you reach 100, then several hundreds, you approach 1,000. This is because, according to the methodology, the phrasing of steps should be high level. It should be spelled out the way a designer would say it, which means that for every feature, you will have to create more and more step implementations. And this promise that you're not going to be writing JavaScript does not stand. On top of that, it is very difficult to navigate the library of step implementations because there are so many of them, and they can be put in a hierarchy in a number of ways, but a folder structure only gives you one dimension to organize them. And then if you want to reuse your steps across different projects, you extract them into an add-on, which makes it even harder to look them up to a point. And there is no IDE plugin that would let you quickly navigate from a step to its implementation, especially if you use custom syntax like I've shown before. So developers tend to implement new steps, even though an existing implementation lies somewhere. So you end up with almost identical implementations with subtle differences in behavior, which cause more trouble. The second problem is that steps are black boxes. They conceal truth. Consider this example. Given there are 3 posts in the database, then the title of the first post should say hello world. By looking at this test, I cannot validate if the assertion it makes is correct because I don't see the seeding pattern. I need to actually look up the seeding step and figure out if hello world is hard-coded into every record, or some set of fixtures is used, or some lorem ipsum generator. And this means that in order to reason about your tests, you need to look up the implementations and have them in front of you, which means that You still work with JavaScript, but it's now much easier to do so. Oh, sorry, of course, it's much harder. The next problem is that steps implicitly depend on each other. When I expand the second post, then the expanded post should contain a comment section. How does the assertion step know which post has been expanded on the page? We cannot assume that it's just any available expanded post, because there can be pre-existing expanded posts. We need to know which one has been clicked. And Cucumber has a good solution for this. All functions that implement steps share the same this context. So the expanding step can write into the context a reference to a DOM element that has been expanded, and the other step can read from it and make the assertion. The problem with it is that developers are smart, and when given such a powerful tool, they can go crazy with it, and the complexity of the test logic increases, and certain steps can depend on certain other steps to be triggered before them, and those dependencies can be subtle. Sometimes even the developer themselves don't realize the scale of those dependencies. When I first ran into this problem at a former workplace, it took me a whole day just to trace what is coming from where, and I was pulling my hair. Nothing was documented, so you can imagine how frustrating it can be. There is a necessity to reference elements on the page from your steps, and a natural way to do it is to use CSS selectors. But if you allow using raw CSS selectors, you will end up with steps like this. And this is absolutely perplexing to a non-developer, but even a developer cannot tell which element is being clicked. Is it a menu item, a post title? Could be anything. And of course, every developer that does this goes straight to hell. But in real life, you cannot fix this with a verbal convention, because there is business pressure. You may have a bug in production. The client is raging. You're stressed out beyond reason, and your deployment is blocked by a missing test case. In this situation, you will not care about the convention. You will be the one violating the convention that you had introduced. Then it is very difficult to debug Cucumber tests if you have integrated Cucumber into your test suite in a straightforward way. Your test crashes, and all you have is the name of the scenario that failed and a stack trace that points at Cucumber internals, probably because it catches an error and then throws something else later. On top of that, more than one step implementation can match a given step because regular expressions can overlap. There are like asterisks, right? So the library that I've been using, Yeda.js, uses heuristics to resolve this. It prefers a more specific regular expression to a catch-all one, but this is never obvious. It never works as expected, especially if you have an implementation in front of your eyes, and you're looking at it, you're thinking about it, so you do not expect some other implementation to execute instead. And steps can contain bugs. Step implementation can, like in a hypothetical scenario, can do the opposite thing to what it claimed to be doing, or it could just do nothing, in which case nothing step will immediately pass and your test will fail later on, and you will be pulling your hair trying to figure out why, and you will be blaming the wrong step. You will be blaming the one that caused the crash. And have to resort to debugger statements. You have to put them in those step implementations. And previously, with a conventional acceptance test, all the JavaScript code is in front of you. Just put a debugger anywhere. But here you have to actually look up those implementations, even if you know what they are doing. You need to debug them. If implementations are in add-ons, you need to use DevTools to find the code which is never found. So we can see how and why Cucumber is hated. But I really, really liked the idea. I really wanted the promises Cucumber made to be true. So I did not give up. I identified these issues and I came up with opinionated solutions to them. I said, Cucumber is not to blame for our failures. It's like blaming a kitchen knife for cutting my finger. So let's see what, I forgot the most important problem with Cucumber, which I gave number 0, meaning like it's the last but not the least. It's that if you're a developer in a small web dev team and you're trying to persuade your team to adopt BDD, you're gonna fail. Even if your team agrees to do it, they will not really be doing BDD with enough scrutiny. They will not change their habits. They will not start writing those user stories and the syntax that your steps can consume. They will not be validating the stories that you have written. So not following BDD defeats the purpose of introducing Cucumber, right? So my solution to this problem was just to ditch BDD, let all my teammates work the way they used to. And I, as a front-end developer who is allowed to make technical design decisions, chose Cucumber for my acceptance tests, but it is not affecting anyone else in the team beyond the scope of the front-end code base. Regarding the problem of the size of the library of step implementations, I realized that a user can do only a handful of types of actions on the page, meaning a user can click something, fill some text into a text field, navigate a URL, and my library of implementations have reduced from 1,000 to just a few dozen of very simple single-purpose step implementations that mostly delegate to Ember test helpers, QUnit DOM, and Mirage. As a result, my library is so small that I can actually keep all the phrasings in my head. I don't have to look them up all the time. And the same steps are used in every feature and every project, so they're battle tested, and I'm certain that they're doing what they claim to do. And since there are few of them, they can reasonably be unit tested. This deserves the pimp my ride meme on the slide. Okay, the next thing is the problem of black boxed logic, of hidden truth. Since my steps are now atomic, doing a single simple thing, they cannot conceal any truth, and the truth had to migrate from inside step implementations into the feature file. So it is now exposed in front of your eyes. Feature files became more verbose, especially in the seeding part, but that's not terribly bad, and tests stay readable. Even a non-developer can figure out what's going on here. So the best part is that now we are able to see where this hello world is coming from and validate if the assertion is correct. Here's another example. According to Cucumber methodology, the phrasing steps should be high level, so it could sound like then the first post should be selected. But what does it mean for a product, in this case, to be selected? It does not have a checkbox. With my opinionated approach, the steps became more verbose, but we can now see what it means to be selected. It is to have a certain HTML class and certain content. So now the feature file is unambiguous, and it contains all the data that you need to reason about it. The problem with tightly coupled step implementations is solved by simply not using this context in any of step implementations. Instead, step implementations reference entities by IDs and indices. This sounds really obvious in retrospective, but it took us a long path to realize that this context actually causes more trouble than it solves. The problem with CSS selectors we solved by relying on semantic data test selectors. So I created a converter that would only accept data test selectors. And this approach is battle tested and proven. Highly recommend to use data test selectors in any code base, regardless of which approach to acceptance test you follow. The only problem with it is that data test selectors are hard to read. So I came up with a custom DSL that would, so we start with a data test selector, ditch the square brackets, ditch the data test prefix, and capitalize the rest so that the selector stands out in the phrasing of the step. You can see which part of the step is a selector and which one isn't. I also chose to reverse the order of compound selectors. So instead of saying, when I click post second expand button, I would say, when I click the expand button in the second post. And this conversion is unambiguous and bidirectional. And you have to trust me on this. It works surprisingly well and very, very satisfying. 99.9% of times where we needed to reference an element on the page, we did using this approach, and it just works. And my syntax allowed like building complicated structures. The only problem with it is with the nth child pseudo class. It does not work as expected. So when I say second post, this means that out of these 5 posts of the page, I want the second one, this one. But nth child would select these instead. So nth child selects the second element in every immediate parent. And it's not the one that I meant, and not one, but 2 elements. So like you cannot click 2 elements with one action. In order to solve this, I borrowed the idea of EQ pseudo class from jQuery. I implemented it with some JavaScript. And how EQ works, so the selector data test post, EQ2, means that find all posts on the page in a flat array and pick the second one using one-based indexing for human-friendly and aligned with CSS approach. As for debugging, I implemented a custom integration of Cucumber into QUnit and Ember, like a wrapper add-on. And what I did was, so here is how QUnit output looks like with my custom integration. You can see every step here, even the passing steps are logged into QUnit, and this is very handy, especially when you have the same step repeating multiple times. You can see which one of them has failed, if it did. The snicker icon here represents the name of the step, and the gear icon is the name of the implementation that runs the step. And this is how I can quickly compare them and make sure that the intended implementation was matched against every step. When a step fails, it shows you a meaningful error message where you can see the name of the step, the name of the implementation, the assertion error, or like an error from your app if it crashed, and a list of arguments that your step has been invoked with. If some of arguments are references to elements on the page, then you will see this human-friendly selector, the CSS selector that it has been resolved to, and the number of elements that have been selected. And this is important because most steps expect exactly one element to be selected, like to click or to assert text content. And most of the time, if a step failed, it's because 0 or more than 1 elements matched. And finally, the stack trace, I achieved this by catching the error before QUnit gets a chance to do it, stashing the error message and the stack trace, then rethrowing to let Cucumber do its thing. Then finally, when Cucumber throws, I catch again and shove my enriched error message and the stack trace into the error. And that's it. When we implemented this approach, we proceeded working on implementing new features for months in a row without having to write a line of JavaScript in the tests folder. And we had a really intense test coverage to a point that GitHub started saying that the language our Ember frontend, many Ember frontends are written in is Gherkin with a dash of TypeScript. And this was fun and satisfying to notice. And I started enjoying writing acceptance tests again. Thank you for listening.